Hello everyone, welcome to my channel Chemistry is Fun. Today we will start and see the topic the solid state. This will help you in your NEET 2024 exam. So we all know that in the solid state the particles are very closely packed. The molecules will be very close to each other. The space between the molecules will be very less. Space is very less. But the intermolecular forces of attraction will be very strong. Strong intermolecular attractive forces. So if we represent the molecules like this, they are very close. We see the gaps between them are very less. No space. Why they are so close? Because they are held together by strong intermolecular attractive forces. Because of this only, they all exhibit some general characteristics. Since the intermolecular forces of attraction is very high, they have a definite shape. The molecules do not leave their space. They are held together at a particular space only. Therefore, they have a definite shape. They occupy a particular definite volume and they have a definite mass. They have very high density. The reason is the same. The intermolecular space is very less, so density is very high. Since the intermolecular space is very less, the compressibility is very low. We cannot compress them because intermolecular space is very less. And because of that only, diffusion will be very slow. The constituent particles have a fixed position, and if we see their movement, how they move, they can only oscillate about their mean position. Only oscillation, to and fro motion about their mean position is allowed. Because of that, their vapor pressure is very less. Because the intermolecular forces hold the solids together, because of that, vapor pressure is also very less. If we see the melting point, it is definite. They have a definite melting point. The transition between solid and liquid is very sharp. And this melting point will depend upon the strength of the binding energy, which binds the molecules together. The solids can be classified on the basis of nature of order which is present in arrangement of the constituent particles. Means whether there is a orderly arrangement or not. Based on that, there are two types, crystalline and amorphous. Let us see one by one. In a crystalline solid, there is a large number of small crystals which have a definite characteristic geometrical shape. There will be a definite characteristic geometrical shape. They have a particular geometrical shape. And the arrangement of the particles is very ordered. Means there will be a regular pattern and that pattern will repeat. We can see in a diagram I have drawn here. You can see there is a orderly arrangement. The constituent particles is ordered. Like say we can imagine a room in which 30 people are sitting. There are 30 chairs which are placed in a particular fashion and the spacing between the chairs is same, equal. So that is a ordered arrangement of chairs, and on that there are 30 people occupying. Nobody is standing, nobody has moved their chairs. There is a orderliness in the room. Same thing happens in case of crystalline solids. The arrangement of constituent particles is ordered. There is a regular pattern of arrangement of the particles, and this arrangement you can see same type of arrangement we see which is repeating. There is a regular pattern of arrangement of particles which repeats itself periodically. After a fixed number of molecules, the same pattern will repeat again. So periodical repeat of the regular pattern. Periodically, the regular pattern of arrangement is repeating itself. Example, we can say sodium chloride NaCl and quartz. Sodium chloride NaCl and quartz. They all melt at a sharp temperature and this is characteristic for that solid. If we cut with a sharp edge tool, they split into two pieces. And new surfaces are plane. What surface we get again? That is plane and smooth again. They also have a definite hue of fusion, and this is characteristic for a particular solid. They are termed as true solids, and they are anisotropic in nature. Anisotropic is a new term for you all. Anisotropy means their properties differ according to the direction of measurement. Same physical property, if we measure along different axes, we will get different values. So anisotropic means properties differ according to the direction of measurement. When the direction of measurement changes, the value of that physical quantity will also change. Now this happens because of this ordered arrangement only. You see in this figure, I have represented the crystalline solid with the help of blue solid dots and violet circles. Now see, if we see the arrangement along the axis AB here, the type and number of particles on both the sides is of a particular nature. But in the same solid, if you consider along the axis CD, the arrangement is alternate. We get one purple round and a solid blue, purple round and a solid blue alternating with each other. So the arrangement is different in when we see the two different axes. So as the direction of measurement is changing along different axes, we will get some different values of a particular physical property also. So this is known as anisotropy. This is anisotropy. You can see in this figure. Next is amorphous solid. Amorphous solid in that there is no orderly arrangement of particles. We can imagine a room in which there are some chairs, some people are sitting on that, some are standing. The space between the chairs is also not equal. Some chairs are very closely spaced, some are far apart. If we have a room like that with people sitting and standing, then we can just compare it with a amorphous solid. There is no orderly arrangement of particles. This figure I have drawn is for anisotropy. Anisotropy. Now we continue with amorphous solid. In that, the regular or repeating pattern, even if it is there, it will be for a very short distance and they are scattered. Like in some area we can get orderliness, but these ordered areas are very small in size, and in between there is a lot of disorderliness which we find. The arrangement is totally different. Arrangement is disordered. So they are known as pseudo-solids or supercooled liquids. And because of this disorderliness, they do not have a definite heat of fusion. Heat of fusion is indefinite. They are isotropic in nature. The isotropy means uniform in all directions. Isotropy means uniform in all directions. Means identical values of a property in all directions. From whatever axis you take the measurement, we will get identical values. Identical values of a property in all directions. Isotropic. Isotropic means identical values of a property in all directions. Isotropic means identical values of a property in all directions. And when they are cut with a sharp-edged tool, they will cut into two pieces, but there will be Irregular surfaces, the surfaces are not regular. Irregular surface we will be getting. These are all amorphous solids. So I hope students you all could understand whatever I have discussed today. Now I have it is like a notes only, you can take it down as a notes. Please subscribe to my channel. Thanks for watching my video. Please subscribe my channel and share the channel. Thanks for watching the video. Thank you all.